review. Does anybody have a specific question they want to go over or they want to check their answer? Anything from the Unit 4 review that you were unsure of or unclear? Nothing? Nobody? It's fine if you don't, but Mac, 12? Okay. Yeah, let me know after I go over 12. I know which one you want to know. Okay, I actually did 12 in another class, but I've got it here. I'll walk you through it. Remember, this is 103-degree angle is an exterior angle. The exterior angle theorem for triangles says that that exterior angle is equal to the sum of the opposite two interior angles. So angle A and B added together should equal 103, which is what I wrote here in red. So then I realized, ooh, I've got an x squared. That's a quadratic. This was in our 4.2 notes if you need to look back at more examples. But when we had a quadratic, we want it set equal to 0 in standard form. So ax squared plus bx plus c form. So I move the 103 over and I combine all my constants and I got x squared plus 3x minus 18. Then it's factoring. So over here, I did my X box. You don't have to do it in this format. This is just a way to organize. But you're looking for what multiplies to A times C. A is an understood 1 here. So A times C is negative 18. And then your B value is positive 3. So what multiplies to negative 18, but adds to positive 3 is negative 3 and 6. So this factors to X minus 3 and X plus 6. Split and solve. Remember, we're trying to see what would make either of these factors 0, because if either one is 0, the entire equation will be 0. That will be the solution. So positive 3 would make this one 0, and a negative 6 would make this one 0. But when I go to check those in my angle measures up here, if I plug in a negative 6 to angle B here, I get 3 times negative 6 is a negative 18, plus 15 is negative 3. It does not make sense to have a negative angle, does it? So that cannot be it. But if I plug in a 3 works because I get 3 times 3 is 9, plus 15 is 24. And then down here I get 3 squared is 9, plus 70 is 79. And the 79 and 24 do indeed add to 103. Does that make sense? Okay. What was yours, Max? 19?
And 20.
Okay. Okay. So on number 19, it says to draw a median. This 19 and 20 were just drawing and marking up a triangle to the correct vocabulary they're giving you. So on 19, we need to remember that a median connects, if my pen will work. Would like my writing to look neater than that. Let's try that again. Okay, so a median connects a vertex to the midpoint of the opposite side. So I could pick, it says draw a median. A triangle has 3 medians because there's 3 vertices and 3 midpoints. So I could pick any of them. So a midpoint to a vertex. So if I choose the top vertex, I need to connect to the midpoint of this opposite side. So this would be my median. But to know that that's the midpoint, I would have to have the markings showing that those are congruent, wouldn't I? So that would be an example of a median. Now I'm going to actually draw all 3 here. I could have drawn it from this vertex, would have to go to the median here. So you could have drawn it this way, and you still would have had to mark those as congruent to show that that's a midpoint. Okay, or I could have drawn it from this vertex to the midpoint over here, and I would have marked these two segments congruent. Does that make sense? So you could have, it only asked you to draw a median, so you could draw any of those. Okay, the black, the blue, or the green. Those are all medians. Okay, and then 20, I'll come back to you, Cadence. Yes, for 19 and 20. In 20, it was very similar, but this one was asking you to draw mid-segment. So you need to remember that a mid-segment connects to midpoint. Now, again, I wrote in mine, I did all three. You only had to, you only had to draw one of these. But to draw a mid-segment, you need two midpoints. So you had to label at least two of these midpoints, either the red and the green, or the red and the blue, or the blue and the green. It doesn't matter. Okay, and then the mid-segment runs parallel to the side that it doesn't intersect. So for instance, this horizontal side is going to be parallel to this blue mid-segment. This right side is parallel to this green mid-segment. And this left side is parallel to this red mid-segment. So I drew all three. You only had to draw one. Number 21 is a great example of just one mid-segment being drawn. Okay, it has DE. They've got parallel markings on DE to BC. And they've got the congruent markings to show that D is a midpoint and that E is a midpoint. And you're connecting two midpoints. That is a mid-segment. All right, Cadence, what was your question? Say that again. A median does not always make a right angle. It can make a right angle, but it's not like a guarantee. Any other questions on the review? If y'all don't have specific questions, I'm just going to go through some that nobody has asked about yet. So then they're covered in a video.
What did you say the answer was for 12?
12, I think came out to 3. Let me go back to it. Yeah, it did.
John?
And this, I'll post the key. This will all be posted after school, so you can look back at this if you need to. And all these videos will be posted. Okay, well, I'm just going to go to page 1 and start filling in what's not done yet. So I'm going to look at number 2. In number 2, AD is a perpendicular bisector. So that's another special segment, like median and mid-segment are special segments. Perpendicular bisector is a special segment. Okay, it runs perpendicular to from a vertex, perpendicular to the opposite, or actually, I just said from a vertex because this example is from a vertex. This one is going from A to the opposite side, and it's got to be perpendicular. But technically, a perpendicular bisector does not have to go through a vertex. Okay, the way that the type of triangle that this is, it looks like it's an isosceles. And maybe it's not drawn to scale, but the way that this is drawn, it's coming from vertex A. It does not have to. So when I say it doesn't have to, like if you had a triangle, maybe like this or something, and I wanted to bisect and be perpendicular to this bottom side, like that doesn't go through that vertex up there, does it? That's what I mean. A perpendicular bisector does not have to go through a vertex. So just keep that in mind. Okay, in this particular example, it does. Now, what makes it a bisector is that it's cutting that side that it intersects at 90 degrees, it's cutting it in half. That these are equal. That's what bisect means, cut in half. So it's perpendicular and it cuts that side in half. So D is the midpoint. So that means that 2x is equal, or excuse me, 2x plus 12 is equal to 5x minus 9. So then it becomes a basic algebra problem where we're going to get x's to one side. I like to move the smaller one, so I'm dealing with a positive. And constants to the other. So I'm going to add the 9 to the left side. And so then I just need to get rid of my coefficient. I don't know why this keeps scrolling up on us. I'm going to divide by 3. And I'm going to get x is 7. Did the question ask us for x? No. The question, I can't emphasize how important it is to go back and read the question. Every time you think you have an answer, go and read what they asked for. So I'm asked to find the side length of CD. So CD is this portion right here. So I need to now plug in a 7 for x. So 2 times 7 is 14, plus 12 is 26. So I could stop there and be done, but I would highly encourage you to plug it into the other one just to double check. What's 7 times 5? 35, and 35 minus 9, that's also 26. So it checks out because they were supposed to come out equal. So we're good to go. If they had asked for CB, you would have to add 26 plus 26, or do 26 times 2. So just make sure you go back and double check what the question is actually asking you to find. All right, I haven't done 3 with any class, so I'm going to look at 3. In number 3, it says that AC is 6, so I'm going to label that. BC is 8, and AB is 9. They tell you that AC, BC, and AB are mid-segments. So I'm going to add some tick marks to show that these are mid-segments. So AB is parallel to GJ. So that means GC and CJ are the same length as AB. So those would both be 9. So what would this total length be? 18, right? Okay, now I'm going to do the same thing with all the other mid-segments. So AC is 6. It runs parallel to HJ. So each of these would also be 6, because that total length would be 12. I'm going to add tick marks here on BC would be the same as AH and GA. So those would be 8 and 8, so that total side length is 16. Now the question asks for the perimeter of GHJ. GHJ is the entire outer triangle. So I want the whole distance all the way around. So it's going to be 16, 12, and 18 all added together. So that's 20, 30, 46. But had they asked for any of these other segments, you could have answered all of these, right? We can find all of those segments because the mid segment is half the length of the side it's parallel to. I think that's it on the front. So let's go to page 2 and look at 7. Now this page starts talking about I think our hinge theorem and our triangle inequality theorem, which I want to say was like 4.3 notes for y'all. I can't remember. It was kind of in the middle of the unit. We talked about hinge theorem and triangle inequality. So number 7 says, given a triangle with side lengths of 7 and 13, what's the range of possibilities for the third side? So I'm going to call the third side X. And I know that when I talk about a range of possibilities, that I'm going to set it up as an inequality like this. I'm going to say X is going to have to be greater than this number, but less than this number. Okay, and we know that the 3 sides of a triangle, when we have all 3, the 2 shortest sides have to add to be bigger than the third, right? So if 7 and 13 were the shortest sides, and it's the biggest side that I'm missing, what's 7 plus 13? So that 20 would have to be bigger than the third side, right? So the third side cannot be 20. It's got to be less than 20. So 20 is going to be the upper limit of the range. See, this says X needs to be less than 20. Okay, so this is the sum of the two known sides that goes here. And then in reverse, what if 7 and 13 were the larger two sides? What if it was a smaller side that's missing? So I have to ask myself, what plus 7 would equal 13? And you can do that as 13 minus 7, right? So what is 13 minus 7? 6. Okay, so 6 is going to be the lower limit. It's the difference. And to help you understand that, let me just explain. Because if 6 and 7 were the lower two sides, the smaller side, 6 plus 7 is 13, and that's not greater than 13. So 6 can't work. It's x has to be, what it says is x has to be greater than 6. So it's got to be greater than 6, but less than 20. That's the range of possibilities that could form a triangle with a 7 and a 13. Make sure your name's on all the pieces. All right, now in number 8, so that's triangle inequality theorem. Number 8 is asking us to order sides, shortest to longest or longest to shortest in this case. That's hinge theorem. We talked about like the hinge when a door is opening. The wider you open the door, okay, the bigger the angle gets, the further the door edge is away from the wall. So the longer the side across from the angle. And vice versa, as you close the door, the angle gets smaller. So the side length or the distance between the door and the wall gets smaller. So when you have the angle measures, look for, in this case, we're starting with longest. Okay. So the longest side will be across from the largest angle. So which of these angles is the largest? Yeah, angle C, 70. So it's across from side BA. So BA is the longest side in this triangle. Then in the middle is the 60-degree angle, which is across from side CB. So it will be the middle side. And then the shortest is going to be across from the smallest angle, which is 50. So that is side here, AC. So those are my side lengths ordered from longest to shortest. Even though I don't know the side lengths, I know that that's the order that they have to be given these angle measures. Okay. So number 9 is a similar question. It's asking which of these can form a triangle. This is like kind of like number 7. It's triangle inequality. But this time they give you all 3 sides. So what I did in our notes and what I like to do is I like to circle the 2 smallest sides because it's the 2 smallest sides that have to add up to be greater than the third. Okay, so the sum of the 2 shortest sides must be greater than the longest side. Okay, so I'm going to underline the longest side in each of these. So when I set up the inequality to check this, 5 plus 4 is 9. How does 9 compare to 7? It is greater than. That's what we wanted. So yes, that can form a triangle. So in B, 3 plus 2 is 5. I'm comparing 5 to the longest side, which is 6. 5 is less than 6. So no, that cannot form a triangle. So you go through and check all of these. So that sum is 6, 10, 11, and 9. And then I'm comparing that one to 5, 8, 9, and 8. So for all of these, the sum of the shorter sides is greater. So all the rest of those work. All of them work except B. B is the only one in this list that does not form a triangle. It doesn't meet this rule. Now, number 10 is another one where we're ordering. Let me do number 10, Cadence. I'll come back to your question. So this time, though, in number 8, they gave us the angles and we were ordering the sides. Now they're giving us the sides and we're ordering the angles. But it's the same theorem that we're using, the hinge theorem. So if I want to order, again, from largest angle to smallest angle, the largest angle will be across from the longest side. So the longest side is 5. So it's across from the largest angle. And also, that's marked as 90 degrees. So we know in a right triangle, the right angle is the biggest angle. Okay, so this one is going to be Q, angle Q. And then the middle side length is 4, which is across from angle P. So that will be in the middle. And then the smallest side length is 3. So it will be across from the smallest angle, which is R. So that is largest to smallest for that one. Okay, so for these last ones, the longest side is 13. So it's across from C. In the bottom one, the longest is 14. So it's across from E. So here, angle C is the largest. And here, angle E is the largest. And then the middle side length here is 10. So it's across from A. And here it's 13. So it's across from G. And then the smallest side is across from the smallest angle. We feel okay about hinge. All right, Cadence, what's your question? Guys, I need those side conversations to stop. I can't hear the question being asked. 25? All right, 25. I did do this in another class, but I'll walk y'all through what I did. The perpendicular bisector theorem says that if you have a perpendicular bisector, which means it makes a 90-degree angle and it cuts in the segment in half. So XY is the perpendicular bisector of AB. That's what we're trying to prove. So I marked it up showing that AB would be cut in half. So D is the midpoint. And then they already have the 90-degree angle marked. So the statements down here that they're saying which one of these would prove that. If you wanted to, if you don't know the theorem, you could draw these into the picture and see if they make sense. It says any point plotted along AB. So anywhere on segment AB, anywhere on the red segment is going to be the same distance to X and to D. There's no way that's correct because look,